In this example, the input signal xn and the impulse response hn are given, and we are asked to determine the output signal. We know that for an LTI system, the output yn is equal to the convolution of the input signal with the impulse response. As a first step, let's write the impulse response in terms of shifted unit impulses. From the given sequence, Hn can be expressed as delta n plus delta n minus 1 plus delta n minus 2 plus delta n minus 3 minus 2 delta n minus 4 minus 2 delta n minus 5. The input signal is simply un minus 4. Now we compute the convolution of xn with hn. Before proceeding, let's briefly review two important convolution properties. The convolution of any signal with a unit impulse is equal to the signal itself. Also, the convolution of any signal with a shifted unit impulse gives the same signal shifted by the same amount. Using these properties, we can immediately write each term of the output. The convolution of delta n with un minus 4 is simply un minus 4. The convolution of delta n minus 1 with un minus 4 shifts the signal one sample to the right, giving un minus 5. Similarly, the remaining terms becomes un minus 6, un minus 7, minus 2 un minus 8, and minus 2 un minus 9. Therefore, the output signal is the sum of all these shifted unit step signals. The only remaining task is to determine where each unit step signal becomes equal to 1 and then add them together. Recall that the unit step signal un becomes 1 at n equals 0. Therefore, un minus 4 becomes 1 starting at n equals 4. Likewise, un minus 5 becomes 1 at n equals 5. Un minus 6 becomes 1 at n equals 6. Un minus 7 becomes 1 at n equals 7. The signal minus 2 un minus 8 begins at n equals 8 with an amplitude of negative 2. Similarly, minus 2 un minus 9 begins at n equals 9. Now let's add all the signals sample by sample. For all values before n equals 4, every signal is 0. At n equals 4, only one signal contributes, so the output is 1. At n equals 5, two signals are active, giving an output of 2. At n equals 6, three signals are active, so the output becomes 3. At n equals 7, four signals are active, giving an output of 4. At n equals 8, we have 4 positive 1s and 1 negative 2, resulting in an output of 2. At n equals 9, we have 4 positive 1s and 2 negative 2s, so the output becomes 0. For all values of n greater than 9, the positive and negative contribution cancel each other, and the output remains 0. Therefore, the final output sequence has the following values. At n equals 4, the output is 1. At n equals 5, it's 2. At n equals 6, it's 3. At n equals 7, it's 4. At n equals 8, it's 2. And for all other values of n, the output is 0. This example demonstrates how to determine the output of a discrete time LTI system using the convolution operation and the properties of shifted unit impulses. If you found this tutorial helpful, please like the video, subscribe to the channel, and stay tuned for more signal and system solved examples.